Okay, today I'm here to talk about a project that one of my coworkers and I started a few months ago. It's had a couple of weeks of work, so bear with me as we go through some of the details. So basically, I'm a project lead on, my name's Charlie Gracie. I'm an employee at IBM, but I'm also the project lead or co-lead for the Eclipse OMR project. So I'll give you a bit more details about that as we get going in the talk, but sorry, I work for a large company. I have to put this slide up saying you can't trust me or believe anything I say. Okay, so this talk, I'm going to quickly introduce the Eclipse OMR project, and then I'm going to go into a quick bit of details on one of the components of the project called JitBuilder, and then I'm going to talk about some of the experiments we've been doing using JitBuilder in Lua 5.3 VM to actually add a JIT to the Lua VM, and then some future work and open it up for some questions. So the mission for the OMR project is to basically create a reusable set of runtime toolkit that any runtime, any existing runtime or any new runtime could use to actually get different components for their runtime. So if you have a runtime that you've spent a lot of time working on, but you didn't have anybody with deep compiler knowledge, well, you can go pick up the OMR project and plug it into your runtime and hopefully get a JIT. JitBuilder that I'll talk about later is making that easier than actually having to understand the 800,000 lines of JIT code that are there. So that's that. And we want to accelerate this for a lot of the current runtimes, or that's our hope. So, and lots of other examples. If you look at some of the other communities, they'll end up doing another VM or something, and there's the Lua JIT VM as well. And so we're kind of hoping with the Eclipse project that you can use these and keep your community the same way as it is. So you can just plug it into your runtime, and hopefully there's no really big differences or problems for using that runtime still, but you get the benefits of a scalable GC if you wanted, or some RAS tooling, or a JIT. So the OMR project itself has no language semantics. As far as on the GC architect, as far as I'm concerned, a GC is a GC is a GC. You have objects. As long as you can tell me what shape they are, I can go collect your objects and watch the memory for you. And we believe that most of the components in all the VMs are kind of similar. So it was originally, the first drop of the code was last March. It's on GitHub. It's dual licensed under Apache and Eclipse. We're always looking for contributors. So right now, this is sort of a quick overview of the components that happen to be there. So if you have a runtime that wanted something, you might be able to consume the one from OMR. The first two are sort of for platform support. So support and thread library. If you used it, it works on Windows, ZOS, Linux, OS X. So you just sort of get the threading and porting of those. GC, a JIT, and then some more sort of diagnostic stuff that you would see from runtimes like Java that you could hook up and monitor at runtime how your application is going, the heap object allocation, and all of those things. So now I'm going to move into JitBuilder kind of quickly. I apologize, there's going to be some code start showing up on the screen. Hopefully it doesn't put you guys to sleep. So what is JitBuilder? It is an interface to our compiler technology to hopefully make it easier for people to get up and going with a JIT in their runtime. We don't believe that using this sort of front-end API into the JIT would ever give you our peak performance that you can get by actually going in and generating IL yourself, intermediate language yourself, and all of these things if you really dug in into the deep internals of the compiler itself. But we believe you could get a significant performance improvement, and it's very straightforward and easy to use using this API. So the code was only contributed on September for this, so it's still kind of work in progress. We're still ironing out the API, changing it, modifying it, and adding new features as we plug it into different runtimes. So actually, the last month we've been working on the Lua JIT probably has only been about a week of work of actually putting it in the JIT into Lua. We've been sidetracked on adding new features and fixing things in the, or fixing the JitBuilder stuff. Where fixing is changing how things work so it could be more useful to other languages. So it's very straightforward. If you were using it, there's a simple initialize and a shutdown API. Put those in your initialization for your runtime and your shutdown, and you're ready to go. But then you actually have to start using it to compile your methods or functions or whatever your runtime has. So that's the bit of the complicated part. So to do this, we've created a method builder. If anyone is familiar with LLVM stuff, some of the terminology is pretty similar, I've noticed recently, as you're doing the same types of things, so it kind of makes sense, I guess. So this method builder is basically what you would use to define what a method is in your runtime. So any parameters that it would have, what the type, like if what's the return you want back, and gives you, and all of the stuff being generated is actually done using system linkage. So basically it's like making a C call when you want to call one of these JIT functions. There's more tricky things when a JIT's calling the JIT later on, but for most part, it's like a C call. So, sorry. The two main parts of the method builder are the constructor, and then there's this build.il method. And I'm going to go into an example to sort of describe those quickly before I move on to the Lua versions of it. So what can you do with JitBuilder? So it basically has these types of operations. So you have all your primitive data types. Of course, you want to be able to do all of your arithmetic, add, subtraction, divide, all of those types of things exist. Then there's conditionals and different systems for doing loopings and those types of things. And then there's a generic call that you can call any other arbitrary C function. Just tell it the function name, give it an address of where it will be, and pass it the right parameters. So most of the operations, used to say operations are typeless, now they're mostly typeless. A few of them actually need to know the type. Once you've been working with JitBuilder, if you have and value that you're passing around doing stuff with, it has a type. So most of the time you don't actually have to say, I don't want to do an add 32. If you're adding two things together, you're saying add on them. If they're both ints, it's going to do the proper one. If one's a larger int, it'll do the right extension or tell you you need to convert it yourself. But there are a few things like load and store at, which are for indexing things out of array type data in your memory. So a simple method builder example. So right away, one of the first things you do is you need to give a name, because these are basically C functions. They can be called by name, and we're setting up a proper C stack for everything. So you name them, and that also allows the JitBuilder itself to be able to call from one to the other. Parameters. So this one is simply going to do an increment. So it takes an int. Return type is also an int32. TypeDictionary is a list of types. So you can actually define your own type. So when we get talking about the Lua one later, if anyone's familiar with the Lua VM, there's the Lua state, there's call info, all of these things. We actually go and have a mapping of defined of all of those structures so that we can actually, if we get the main parameter when we get to the Lua one will actually be the Lua state. That's what's passed into the function. So to be able to get everything off of it, we can do a bunch of like load in direct instructions or things, and we just pass it the field name that we want out of the particular one. So these TypeDictionary allows you to use the generic int, Boolean, or double, it's probably not a bool, but then also define your own complicated ones. The Lua ones have actually driven a lot of change in because the structures there are full of unions. It's a union of all these different types, so we didn't actually support that before, so that's been most of our work in making sure we can alias the types properly on the JIT side. And then the other part, so that was the constructor. The body of the function, the build.il, would just be add this value that's passed in as a parameter to a constant one and return the value. So in the end, that would actually just generate some very simple C code for taking what was passed in a register on x86, adding 1 to it, and putting it in the proper register to return. That was the value that we were talking about. So one other thing about the builder stuff is to actually be able to do control flow, so different code paths. So if you were looking at a method in the interpreter for Lua, something like add. If your type is an int, you do this type of add. If it's a float or if it's just a number, you do a different type. So to be able to handle these control flows, we have basically this stuff set up so you can actually do different builders. So this one is you create a couple of builders so that you could do the pass with them. Then you would do if then else. So in this case, the then and else path are the builders that would be executed depending on the condition. So the condition here is less than, if A is less than B, then you would do the if path, the then path, or otherwise you would go down the else path. And this is just going through quickly talking about what the value would be in the end, either 1 or 0. So again, type dictionary to cover this quickly. So when you want to define a struct, now you can define unions. Basically, what you would do is you give it a name for the struct, and then everywhere inside, you would actually just give it that same name, and then you just give it the name of the field. So usually you make these match up to the C struct or the C++ class. We're looking at trying to find some way to actually have this automatically do it for you. If you could give it the header file that it's contained in and say generate me one for this struct, but that's just something we're looking into for the future. And one last thing about this is most of the JitBuilder stuff is very generic. So you could use it for anything. You could go write your own little program to do whatever you want. But to actually make it easier to do interpreters, which is kind of the focus of what we're looking at, we've gone a step further and kind of created this bytecode builder or opcode builder, depending on your runtime, which allows you to do, it handles a lot more of the flow for you, because if you look at some bytecodes like jumps and gotos, they actually can sometimes fall through or go somewhere else. So to actually keep the IL that we're generating a lot cleaner and make it a lot easier for the JIT to optimize, we've gone and added this so that we can give hints at least how the control flow is going to happen. There's a great talk on this that I have the link to here. One of my coworkers. So Lua Vermelha, my coworker created it. The name, I don't actually know where he got it from. That's what's on there. So we started working on this in about January. So it's there, it's on GitHub, it's under his right now. We're not sure if we would ever move it anywhere else if anybody cares, but so that's the link for it. And we're basically, the main goal is to actually just integrate it into the Lua VM with as minimal changes as possible. At this point, we're at only about 30 lines of code, I believe. It'll be on the slide later, of changes to actually be able to use the JIT. So the JitBuilder design that we decided to do for Lua was we do all of the compilation synchronously. We could have another thread or something to go do some asynchronous, but which is probably a future. But for now, we just do it asynchronously after so many executions of the method. I don't remember the number offhand, but I believe it's 10 or something right now. After you've executed something 10 times, you'll go and JIT it, and then from then on, you'll execute the JIT it version. So the major change to the interpreter was in do call in the interpreter. So basically, if you get to the point where you're going to call a function, once you get the prototype, if it has a compile code, you just call that directly, or you just let the interpreter continue going. We keep the Lua state and call info up to date everywhere. This allows us to fall back to the interpreter at any point we want. It causes a bit of perf loss here and there because we're updating things needlessly at times. But for now, right now, the whole idea is we'll just keep it completely up to date. And at any point we make a decision or we see something that goes against our decisions we made in the past, we just fall back to the interpreter. And that's, we let the interpreter handle all the complicated cases right now. So the Lua FunctionBuilder method will look pretty similar to the basic one I showed before. But really the main thing we take in for parameter is the prototype. So in the Lua VM, anytime you have a function that you're going to call, there is a prototype, this proto-struct, and we use that to actually go and generate all of our code because that has the pointer to your your array of opcodes and all of those things. So build IL for it. The first thing I do is this code is not complete. It would not fit on one page. It'd be multiple pages, so I just have some quick examples of what the code looks like. So create the bytecode builder so that we could go and generate all of the code. The first thing we need to do, so this kind of looks very similar to the top of the bytecode loop in the interpreter. So you go fetch the call info off of the Lua state, and you fetch base, which is the base for where all the registers are that are going to be used. And then you fetch the next you would loop over all of the instructions for the code. And then you switch on the code and handle the appropriate ones. So this looks a lot like the interpreter itself. So if we really wanted to be crazy, we could actually go and macro up the interpreter itself so that the code could actually be shared. But that really complicates the code on the interpreter side for no real reason. Having this loop over here as well doesn't hurt anything. So we've opted to do that. So that was do move on the screen a second ago. So this is basically the code from the interpreter for do move. It copies the value from register RB into RA. Very straightforward. So the JitBuilder version of do move. So the first thing I'm going to do is get RA. So I'm going to go load that guy. And then I'm going to get B. So RA, we know that basically every opcode uses the RA register. So we load that all the time in the main loop. It's always up to date. So, but here I'm going to go, we have another convenience helper just for going and fetching the RB for us. So call that. And then it's basically the same thing. We have a helper for set object, which is down below here where we just fetch value and type out of the source object and store them into the destination object. So that would be generating complete IL for that function. But to start off, and actually the very first thing we did is we actually didn't implement IL for any of the methods to start out. We actually just went and basically took the interpreter and created little C functions for every piece of code that was in there. And that actually kept us very honest and making sure we do keep the state and everything up to date all the time because we were actually just relying on the helpers for everything. But this is an example of when we haven't gone back and actually generated the IL for it in particular. So the AND one. So all basically we have is a function that we call for this one. So you have a bunch of the code happening in line, and then you would see a call out to some C function and then continue exiting in the JIT. It's not falling back to the interpreter. This is a helper that we've created. So the VM band, anytime we make a call, because we have base stored in a local for us, we always make our helpers return base in case the stack happened to grow or something. Again, it's pessimistic at this point. We could be more clever, but we just always do it for now because we don't have, the expectation is we won't be calling these helpers very often because we'll finish implementing the code for the rest of them. The CI and stuff again, but the code is basically identical. And this is just for us to be able to do helpers quickly to make progress and be able to show some performance improvements later. So this one is basically the meat of the entire change to the interpreter. So basically, this is exactly what we changed. Other than adding a few fields to the prototype structure itself and setting those up, this is basically the code. So once you're decided you're actually going to call a Lua function, we check to see if it's already been JITted or blacklisted to say we can't JIT it. Oh yeah, one thing that I don't have on the slide is we've actually created a helper, our own little extension for Lua, to be able to actually completely direct if you want to go have a function compiled. You could just say, as long as you import the right library, you can just go say compile this method. That meant we then created this black and white list as well, so that you could say never to compile something for our testing. So that's the quick check. If it's not blacklisted and the counter is at 0 and you've never compiled it, go compile and then blacklist it so it won't be compiled again. Then if it is compiled, go just execute that compiled code. And if not, decrement the counter. The good part is of the way that Lua VM actually works here is you would have just set up the state for the call. So when we come back, we actually don't have to do anything fancy because we'll have set up for the next call. The interpreter loop will just jump back to the beginning, load all of the right things, and keep going, or load the stuff for this current one. So performance. We added a JIT. You would expect some performance. If you've been familiar with the Lua JIT, this performance numbers are not going to look anywhere as good yet. But very quickly, for some things like fib and Mandelbrot, very quickly, like a 2 to 2 point something x performance improvement. So basically, we did very minimal changes to the interpreter, and very quickly, you can see over 2x performance for a lot of these little simple workloads. Add test is something I created myself. It's a loop just basically adding a bunch of values together, all from that would end up being a register, so I really want to test that through. Because it's mostly math, and that we end up generating here, and there's no calls or anything, that one right away is 5x faster. And factorial, everyone knows what factorial is. So the current state is there are a few opcodes we just haven't even created the helper for because we've never ran into any code that actually generates those. So if you did have code that did it, I think it's like load xk or something, load some other one anyway that I've never seen. It's a constant when you have more than 32,000 constants or something. We haven't even bothered, so if you did, you would fail to compile and we wouldn't run JIT it for that one, but we'll do it eventually. So in total, we're at less than, I guess, 50 lines of code, including the makefile changes and everything. And we wrote less than 2,000 lines of code to actually be able to do this on the JIT side. So our JIT Lua FunctionBuilder, where a ton of that is actually the loop, the switch statement, like that actually consumes a lot of the lines, so it actually isn't very much code. So some future work that we're going to plan and actually have a lot of it started right now is we want to get rid of 100% of our VM helpers for all the common paths. We believe we'll still end up with some, again, because we want to let the interpreter handle the hard cases. If you're trying to add a string to something else, I'm not going to probably do it to begin with because I don't want to convert the string to an int or whatever to do the math. Fall back to the interpreter for that one. Whenever possible, one of the things we've noticed in our JIT right now with this is I was expecting to see some way better perf on especially some of the math only, like Mandelbrot and those things. I was expecting way more than 2x. But the problem is every time we go to do a math operation, I have to check, is our A an int or a double? Is our B an int, or sorry, B and C, are they ints or doubles or what are they doing? So it creates all of these diamonds in the code. So the JIT has a hard job actually optimizing down through. But very recently, like when I was on the plane on the way over, I was doing some work by actually keeping track in the interpreter of what the types were when they were called. And if I do that, then I can actually assume based on the instructions that are taking place, like if you do an add of 2 ints, it's always an int. So I can always know the type what the result would be. If I start doing things like that, I can see some very significant improvements. Like Mandelbrot's like 10 to 15x faster. this is where in the ballpark I really want it to be in a bunch of these things. So that work is sort of in my laptop right now and not in any state to show anybody, so I don't want to talk about those numbers, but that's something that we want to do and keep going with that to actually be able to do it. And the good part is if we do it based on the input parameters, at any point if they actually were not the right type, we just fall back to the interpreter and keep going. You would have a big perf loss if you called them in opposite order all the time, like if you pass it an int now, then float, then int. But we also quickly hacked in that if you ever fall back more than n times from the interpreter, we could actually go back and re-JIT without the other information, so that then you could handle you would do the checks in the JIT, but you could do more and still get the 2 to 3x perf. So to quickly wrap up, just to cover again, our mission for OMR is to kind of make this toolkit available for these other runtimes. We really don't want to create a new community. We don't want to do anything to harm any of the communities. We actually are just trying to make these available so that they can work with the communities that are already there. A lot of these languages have very large communities. So we're hoping that we can work with them, and not saying our tech's the best. Actually, the more people to use it, we may actually get some improvements ourselves by having some of the other smart people working on these things provide stuff back to us. Check out our Lua VM from the link if you want. Give it a compile, use it. It should be fairly stable. We test a lot before we commit anything. And again, that's just my quick contact information and the link again here to the Lua VM. That's it. Any questions? I don't have a question slide. I'll go left to right back here.
One of the big strengths of Lua VM is the small.
Yep.
What kind of footprint does OMR have?
So on disk footprint, right now we've increased, I want to say it's a couple of megabytes that we've increased. I can get the actual number. It's
150, I believe.
200.
The original Lua, I believe, is 150.
K?
K.
Yes. And we're like
a couple of megabytes.
Yes.
Okay.
Yep. Yeah.
Did you do you depend on specific flags in Lua, in the Lua config file? For instance, if you change the number type of does it still work?
Yeah, it still works. So we actually, when we create the structures that we do all of those things based on, we actually are doing it based on whatever the size of Lua Lua integer and all of those things. For what we've tested, it all seems to be working that way and going.
Because you were talking about, for instance, coercion, you can disable that. So you can say, I want no coercion between strings and numbers.
Yep, exactly. And then we would never have to jump back, exactly. We're starting to put some of those checks in as well as we keep going, but for now we just bail on everything we don't recognize. Here.
Do you plan to extend that to other languages except for Lua? That's one question. And the other, do you believe you can get close to Mike Paul's Lua JIT? And if not, why choosing Lua then for this example of your JitBuilder?
I'm sorry, please repeat questions for the
Oh, yeah, okay, sorry. So the first question was, are we planning on using this for any other languages? And the second question was, do we believe we can get anywhere close to the Lua JIT performance? I believe you said Mike Paul is the guy's name? Yeah. So the first one, yes. I've got another small language that I've implemented this for that is not really used anywhere. It's a Smalltalk derivative. Again, that was just our first prototype of it. We are doing this for Ruby MRI as well, not using JitBuilder, but the JIT itself directly. We've had people present at the last 2 Ruby Kagis for that. That's making slow progress. Ruby's actually very difficult because for MRI, all of the class libraries are written in C, so it's very hard for us to see through it. You have to actually write a bunch of the code in Ruby to make it easier, but it's used in our IBM's Java VM. This is actually 100% consumed back into our builds every day for Java. And we're looking at a few other things at this point, but nothing concrete enough to bother talking about. And the performance, I don't know. I have to do more comparisons. I saw quickly his chart on the perf for a bunch of things. Lots of things were in the 10 to 40x. That's completely doable, depending on what we can do here. But then maybe I missed some. Maybe he's got 300x on some things I didn't see.
So did you measure the performance at all for this?
Of this, yeah. So for a lot of these things, I'm 2 to 5x faster than the interpreter by itself, but I haven't done any direct comparisons to the Lua JIT itself.
Which interpreter? Lua interpreter?
Yes,
or
Lua.
JIT?
Lua interpreter.